Linear equations. To algebraically solve an equation means to find, by showing all logical steps, the value of the variable that makes both sides of the equation equal. So what does that look like? Well, if I take the example x plus 5 is equal to 2, I want to try and find an x value such that that value plus 5 would be equal to 2. So both sides of this equation, the left-hand side and the right-hand side of this equation would both be equal. And to do that, I have to show the logical steps. So one thing that hopefully you learned in the past that you are allowed to do is you can add and subtract the same amount to each side. So this kind of makes sense. If this is a balance, if both of these sides are equal and it's in balance, if you add 1 to this side, suddenly your balance won't be balanced anymore. One side will be heavier than the other side. So if you add 1 to one side, you would have to add 1 to the other side to keep it in balance. And that's the idea of these logical steps. Whatever you do to one side, you have to do the equal thing to the other side. So in this case, I could subtract 5 on this side and subtract 5 on this side. X plus 5 take away 5 would just be x, and 2 take away 5 would be negative 3. And we can always check to make sure this works. Negative 3 and 5. Does that equal 2? Well, negative 3 plus 5 is 2, and 2 equals 2, and we're happy. Let's take a look at another one. If you have 2x is equal to 7, well, now what I want to do to one side, and I'm also going to do to the other side, is division. I can take this side and I can divide it by 2. I can take this side and divide it by 2. 2 divided by 2 is 1. Don't write 1. So there's our goal. Our goal is to get one variable by itself. And the variable in this case, x, is now by itself. And 7 divided by 2, I can leave that as a fraction, or I could write that as a mixed fraction, or I can change it into a decimal. It really doesn't matter. All of those are equivalent. Since it doesn't matter, probably just leave it as the first one as long as it's a reduced fraction. Let's take a look at a couple more examples. What if you have 3x take away 1 is equal to 4x plus 2? Well, it does get a little trickier because I need to get all the x's on one side and get all the numbers onto the other side, and then do the division or multiplication last. So I'll do that by subtracting 4x from both sides. And so I get negative x minus 1 is equal to just positive 2. And if I add 1 to both sides, I get negative x is equal to 3. And then I can divide both sides by negative 1. And x is equal to negative 3. And I can go ahead and do my check. 3 times negative 3 minus 1, is that the same as 4 times negative 3 plus 2? 3 times negative 3 is negative 9 minus 1. That's negative 10. And on this side I get negative 12 plus 2, which is negative 10, so I know I've done this right. And this is a great thing for this unit. If you do these little checks on the side, then you'll basically know whether or not you have every single question right in this unit. Okay, let's take a look at how tiles can help us solve these. If you're not quite understanding these steps that I just showed in this example, tiles can also help us do this. So let's take a look at that example. So we're going to try and solve with algebra tiles 4x plus 1. So here's my 4x's and a plus 1. And I'll just draw a line to show the equals sign. On the other side I have 2x minus 5. And what I'll do next to it is just draw the steps that I'm doing out. So you can see on the left hand side I've got algebra tiles, and on the right hand side of this little squiggly red line I've got the algebra steps that correspond to those algebra tiles. So if you want to just learn how to do it just with the tiles, you can watch the left hand side. If you want to see how it relates to the algebra, just watch the right hand side, and you can hopefully look back and forth. So if I were just looking at the algebra, then I would want to subtract 2x's from both sides. So I would subtract 2x on this side and I'd subtract 2x on this side. In algebra tiles, that's the same as adding in two negative x's. So there's that step. So negative 2x is right there as negative 2x, and it's on each side of the equation to keep it balanced. Then I start looking at canceling. So these two positives cancel out these two negatives. That would leave me with 2x plus 1 in terms of the algebra tiles. And in terms of algebra, I'll write it over here, 2x plus 1. And then on this side, these two x's cancel these negative 2x's, and I would just be left with negative 5. And I'll write that in algebra and in algebra tiles. The next thing I want to do is subtract 1 on each side, and subtract 1 looks like add another negative tile in, and these ones cancel out. That leaves me with 2x's, and on the other side negative 6. And the last step is to divide into two these groups. So you can see I've kind of cheated a little bit. I've divided these into two equal groups, and that means one of these groups, one of these x's, would be worth negative 3, and I can see that when I look over onto the right hand side. 2 divided by 2 is 1, and negative 6 divided by 2 is 3, negative 3, and so there I have the solution to this equation in algebra on the right hand side and in algebra tiles on the left hand side. Let's take a look at a word problem using some algebra. Work with this question. The perimeter of a triangle is 86 centimeters. And one hint when you're working on these questions is start to draw out what you know. You know you have a triangle, and you know that the perimeter is 86 centimeters. And just to remind you, the perimeter is the distance all the way around those edges, so it's the total distance around. Some more information. One side is 1 less than double the smallest side. Okay, let's translate that. So we've got a smallest side, let's call it x, down here, and another side is 1 less than double that smallest side. So the smallest side was x, and 1 less than double. So double is 2x, and 1 less than that is 2x minus 1. Okay, let's go to the next sentence. The largest is 3 times the smallest. And this is really how you should go about analyzing these, just a sentence at a time. Get that information down. So the largest side, looks like this side here on my picture, is 3 times the smallest, so 3x. Okay, I can kind of guess what the last sentence is going to be, but it is find each side's length. Okay, so the perimeter in algebra is x, and well, that's that part. And then I got to go up this way, 2x plus 1, and then I got to come back down, 3x. And that perimeter is equal to 86. So let's see if we can solve this. Collect like terms. 2x and x is 3x, and 3 more x is 6x. Subtract 1 on both sides. And notice I didn't show the subtract 1 on both sides. That's fine. We can start skipping some of those steps. Divide both sides by 6. And my x value is equal to, and you can write it as 85 over 6, or you can change it to 14.16 repeating. So I do know one of my sides, so I know that my smallest side is 14.16, so let's write an answer here. Sides are 14.16 repeating centimeters. My second side will be double that minus 1, so just take your calculator, multiply it by 2 and subtract 1, and you'll get 27.3 centimeters. And the last side will be 3 times 85 over 6, or 42.5 centimeters. And let's just look at what I've done. I drew a picture which helped define my variables. I set up an equation. I solved my equation. And then I used my solution to answer the question. When you do that, make sure you write it in a sentence and use proper units. Okay, we'll take a look at one more example of a word problem. Okay, and again, let's break this down sentence by sentence. A father is 3 times as old as his daughter. Okay, I need to define my variables, and the easiest way to do that's going to be with some letters and some chart. So I like to draw a chart that looks a little bit like this for these age questions. It's got the father, and it's got the daughter, And right now, if the father is F, and I choose F because it's the letter that begins the word father, and when I solve for it, I'll know exactly what I've solved for. Well, the father is 3 times as old as the daughter. So if I have a daughter, the daughter is a fraction of the father's age. I don't really want to work with fractions, so maybe I'm going to change my variables, make the daughter D, and the father will be 3 times D. And then in 5 years, well, the daughter will be 5 years older, and the father will also be 5 years older. And if I compare their ages in 5 years, I'm into sentence number 2. So here's the father, here's the daughter. Those are their ages in 5 years. So I've done this part of this sentence. His age will exceed twice hers. So I'll have to take hers and double it. That will be twice. And his will still be bigger. So this will still be too big. So to make them equal, I need to deal with this 9 years. If this one's bigger, I need to add the 9 years to this side. Or I need to subtract the 9 years from this side. It doesn't matter which one you do, but you have to deal with the twice as much and 9 years. The key is figuring out how to make it equal. Okay, once you have your equation, we can go and solve it, and our answer for D will be the answer to our question. So now it's simply an algebra question, 3D and 5, and distributive law, 2D and 10 and 9, subtract 2D, so that's D, subtract 5, so 19 take away 5 is 14, and write my answer with units in a sentence. Done.